Hello, my name is Kimon Jefferson, and I'm a part of the SASA program with the dual enrollment to get high school students involved in the engineering program at Albany Tech. And this is Ms. McGee.
Hello, I'm SASA math instructor.
Yeah, and we're going to be showing you today how the Titan Alliance robot actually figure out the math way to fire off a decent shot that's accurate and can be applied with math using the Pythagorean theorem and SOHCAHTOA. So this is what our problem was. We had to get the area assist ball into the goal, which is the goal is 7 feet high. So we already knew that our robot is kind of like a triangle. So that's what you need when you use the Pythagorean theorem. It's a triangle. So it's a triangle on wheels. So we have to set up the equation. So this is our triangle right here. We did a test fire, so we actually knew the power of our robot. So we can actually shoot like 9 feet distance, but we need to get it an accurate shot. So what we did here is drip the triangle with the goal. As you can see, the goal was 7 feet high and was 9 feet back, as we have here. And the angle of the goal and from the ground makes it's a 90-degree angle. That's what you need for a right triangle. So our only problem is we have to find which angles that we have and solve the Pythagorean theorem. So the Pythagorean theorem is a squared plus b squared equals c squared. So what we did we plugged in. So we got our a 7 squared plus our b 9 squared equals c squared. So 7 squared is 49 plus 81 equals c squared. So by that we have 130. Square root of 130. So square root of 130 in decimal form. It's not exact because you don't have the radical, but we needed a good estimate. So it'll be 11.4. So 11.4 is our hypotenuse. Not knowing that it was our actual farthest maximum distance. So I found that out as we went along and we got a couple shots off and we wanted to test our distance. Not knowing that I had it in my hand, I actually found out that it was 11.4 was our maximum distance that we could shoot. So we needed to find out an accurate angle to find out how we would enter the ball into the goal. So, erase this. So to find an angle, we would do the inverse of SOHCAHTOA or the inverse. Right?
You use the inverse of 10 to find the angles. So since we know the side opposite, we can say the inverse 10 of 7 divided by 9, and we compute the angle.
So we will get 10 negative 1
7 divided by 9.
Of 7 over 9 equals, that equals, when you put it in the calculator, it'll give you 37.87. So we knew that was our angle right here, because as you see, tangent is opposite
over
adjacent. So we have our opposite angle, and we have our adjacent, which is running along the angle right here, what we're looking for. So we know this angle is 37.87. So to figure out our next angle right here, a whole triangle is 180 degrees. So we already have our 90. So these two have to add up to be 90 degrees. So we will subtract 90 minus 37.87, and we will get 52.13. And that's our other angle of the goal right here, 52.13. And that's how we found the accurate shot. If we go with the ball going in with the decent shot, find our maximum of our shot. But if we wanted to come up, if we wanted to make a closer shot, we know we had to alter our angle. But that's it. Thank you.